Hey, welcome back to Mr. PL's Algebra 2. This is Unit 2, Topic 1, SLT1 still. This is 1B. We're going to explore how to factor with leading coefficients in this video. So in the last video, we did this one, which is factoring without leading coefficients. In other words, when there is an A that is 1. So this is A, this is B, this is C. 1 times 36 is 36. And you figure out what two numbers multiply to get 36, but also add up to 12, and that would be 6 and 6. 6 times 6 is 36, and 6 plus 6 is 12. Check. Alright, so 1 times negative 6 is negative 6. Factors of 6 are 1 and 6 and 2 and 3. The combination that's going to, remember, one of these numbers has to be a negative. It's this one, and the 6 has to be the negative one, because if this is negative on the inside, it has to add up to a negative. So the only way it's going to add to a negative is if that negative is the bigger one. All right, factoring out GCFs over here. So all three of these numbers can all be divided by 2. And that leaves me with an expression. This might be factorable again. So 1 times 4 is 4. 1 and 4, and 2 and 2. Nope, no way it's going to equal negative 2. So not possible. So that's the answer. So the last one, divide the negative 3 out, and you get this. Oh, they both have an x. I didn't realize that. They both have at least one x. So that's going to leave this with just x, and this as minus 3, and there you go. It's factored as possible. Factored as much as possible. You can check the last video to see this homework. Leading coefficients. Okay, so I've seen multiple ways and styles of doing this, and I'm going to show you two of the styles for this video. I'm going to do the same thing I've been doing. 2 times 3 is 6. Factors of 6. And there they are. So which one of these adds up to 5? And that would be 2 and 3. So I'm going to split that 5x into 2x plus 3x. Alright, now once I've done that, I'm going to split the problem in half, factor out the GCF on both sides. These two terms can both be divided by 2x. These two terms can both be divided by 3, which also gives me x plus 1. Notice that both parentheses are going to be exactly the same, so the answer is x plus 1. What's in the parentheses is one of the factors, and then take the two outside GCFs and put them together, and that gives you 2x plus 3. There's your two factors. Same thing for this one. So 2 times negative 3 is negative 6. 1 times 6 and 2 times 3. The only one that's going to add up to negative 5 is, let's see, this one. This is kind of like the warm-up question. So that would be negative 6x plus 1x. Alright. Divide both by 2x, and that gives you x minus 3, and divide both these by 1, and that also gives you x minus 3. So there's your answer. So you got x minus 3 is in both parentheses, so that's one factor, and then the other factor comes from the two GCFs put together. So your 2x plus 1, there you go. Now for the next question, this one's going to be prime. 3 times negative a is negative 24. Now there's a lot of factors of 24. But none of these factors are going to add up to negative 14. And I know you're thinking the 2 and 12, but the 2 and 12 does not add up to negative 14. You'd have to make both of them negative, but a negative times a negative is not a negative. It's a positive. So there is nothing that works here, so this is a prime expression. There's no way, there's no two factors of this. There's no number times another number equals this. And for this one, okay, so 3 times 4 is 12. So it's either going to be 1 times 12, 2 times 6, or 3 times 4. And it's 2 and 6, so I split this up. Alright, split the problem in half. Biggest thing they can both be divided by is x. That gives you 3x plus 2. Both of them can be divided by 2. That also gives you 3x plus 2. So there's your answer. X plus 2, the two GCFs combined, times 3x plus 2, which is what you got in both parentheses. Alright, so I told you I was going to show another method. I'm not going to do all these problems, so I'll do this one right here. So I'm going to make a box, and I've been locked out. There we go. Pen froze. So I'm going to make a box, and 4 squares. I'm going to put the first term in the upper left-hand square. I'm going to put the last term in the bottom right-hand square, and I'm going to do the same thing I did before to find out the other two terms. 4 times negative 12 is negative 48. I need to figure out the split of negative 48 that also adds up to positive 13. Looking for two numbers 13 apart from each other. It's not 1 and 48. It's not 2 and 24. It could be 3 and 16. Yes, it is. That's what it is. So it must be negative 3 and positive 16. So I'm going to put negative 3x and 1, and then positive 16x over here. So negative 3x. You put a negative right here. Negative 3x and positive 16. Okay, now just do the GCF going all directions. GCF of these two terms would be 3. GCF of these two terms would be 4x. GCF of these two terms is just x. GCF of these two terms would be 4. So there's your answer. 4x minus 3 on the left-hand side times x plus 4. Double check that. 4x times x is 4x squared. Check. Negative 3 times 4 is negative 12. Check. Outers, 16x minus 3x, as we said right there. Boom, that equals 13x. It works. Okay, one more of these. Make my square, split up into 4, put the first term right here in the upper left, put the last term down here. Now I got to figure out the split. 4 times 1 is 4. What two numbers are going to add up to 4? That'd be 2 times 2. So positive 2x and positive 2x. Both these numbers can both be divided by 2x. These numbers can both be divided by 2x also. These numbers can both be divided by 1. These numbers can both be divided by 1. So it looks like it's a perfect square of 2x plus 1. 2x plus 1 times itself. It's a perfect square. All right. I think that we have hit that. So let's get into solving equations. Now, what's the purpose of factoring? Well, one of those purposes is if you have a graph that looks like this. Okay, I missed that very poorly. Let's try that again. Not too much better, but whatever. So when you have a graph that looks like this, its x-intercepts are the solutions. So negative 3 and negative 1 would have been the two answers to this graph. Those are the two solutions, or zeros, or there's lots of ways you could say this. So standard form is always ax squared plus bx plus c. So when you have an a, a b, and a c. Vertex form is when you have a times x minus h squared plus k. And then intercept form is when you have your factors. So it's x minus something and then, or x plus something else. So a and b, two numbers. Those are your two factors. This and this would be your two factors. All right. So when you have zero product property states that anything times 0 is 0. So what that means is there's two factors here. It's this parenthesis times this parenthesis. Whatever it takes to make either parenthesis 0 makes the answer true. So what you do is you set each parenthesis equal to 0 and solve. So that means this one's already 0. So x is 0 is one of the answers and x is 3 is the other answer. Okay, same thing here. So this time you have three factors. You have a negative 1 on the outside, x plus 1 and x plus 7. Set each one equal to 0 and solve. Well, if you set negative 1 to 0, it doesn't work, and that's an imaginary answer. Set x plus 1 equals 0, it gives you negative 1, and x plus 7 equals 0, it makes x negative 7. So if you put negative 1 into this parenthesis, negative 1 plus 1 is 0, and negative 1 plus 7 is 6. 0 times 6 is 0. Because it didn't matter what this one is. This one was 6. Doesn't matter. Once this one was 0, anything times 0 is 0, so it works. And this one, you're going to get a fraction. 2x equals 1. Divide both sides by 2, and you get 1/2. So 1/2 is what it takes to make this parenthesis 0, and it looks like negative 5 is what it takes to make the right parenthesis 0. Two solutions. Now, before I go any further, I know I'm running kind of low on time. I want to talk about how many solutions quadratics can have. Quadratics can have two solutions like this, two x-intercepts, one x-intercept, or there is one other possibility, which means a quadratic has no x-intercept. So quadratics can never, you can never flip this over or make it wider. You can never make this parabola ever hit this x-axis more than twice. It's not possible. You can have imaginary answers like we talked about here, but there's only going to be two real answers. All right, factor and solve. Okay, so now we have to actually combine what we've been doing, which is factoring. And I'm just going to do one of these. I know I'm running low on time. Oh, what happened here? Okay. X times negative 50. 1 times negative 15 is negative 15. 1 times 15. 3 times 5. And I believe it's 3 and 5. And the 5 has to be the negative one. All right, so that's x. Oh, I'm sorry. 5 has to be a positive one. X plus 5. Bigger one has to be positive because the middle term is positive. Now that I've got set it equal to 0, I'm going to use zero product property, which states that anything times 0 is 0. I'm going to set each factor to 0. I get negative 5 for this side and 3 for this side. So, okay, basically I'm just taking everything I've done before. I factored it first, and then I solved it. All right, homework. Leading coefficient out in front. Great. 3 times 2 is 6. Factors of 6. And the one that's going to add up to negative 5 is negative 2 and negative 3. All right, so there's my split. Or I can make the table. Okay, I'm going to use the square method. 3b squared here, 2b here. Okay, I would have factored out the GCF first, sorry. So that's b times 3b minus 5b plus 2. So I factored out the b first. Okay, so now I can put negative 2b here and negative 3b here. These can both be divided by 3b. These can both be divided by 2. These can both be divided by b. These can both be divided by 1. So there's your answer. 3b minus 2 times b minus 1. All right, I think I'll do just one more. Okay, this one's actually easy. Both of these can both be divided by k, and I think that's it. 7k plus 9. These have nothing in common, no GCF. It's not a perfect square. It's not differences of squares. Nope, that's the answer. All right, and this one you do the same thing. So do 2 times 21 is 42. Figure out the split, and then you can go through the rest of the process. I'm actually going to let you do that one yourself. Thanks again for watching. Please give it a like if it helped you learn something about factoring with leading coefficients or on solving equations by factoring or using zero product property. Thanks again for watching. Have a great day. Oh, and it's not letting me pause. Never had that happen before.